for joining today's session on ductwork construction and its impact on energy efficiency. My name is Anna Turning, and I'll be facilitating this session. CIBSE would like to recognize the traditional owners of different lands, countries, and places that all of us are engaging from today. We also would like to pay our respect to all elders, both past and present, and extend that respect to our Indigenous people who are present here today. A few housekeeping rules. This session is recorded, so if you can keep your mics muted, that will be great. And this session will be available for you to watch on the CIBSE NZ CPD webinar webpage. CIBSE NZ has a library of recordings already, and one of the recent one was on the updates to 1668 part 2. If you missed it, please check it out. And we'll have Q&A session at the very end, but if you'd like to leave the message, you can leave it in the chat. We'll review all those questions later on. And to cover a few important announcements, CIBSE 2024 Young Engineers Awards are coming up. The ceremony will be in Sydney. If you haven't already, please make sure you book your ticket. It's generally a great night for building services industry to come together, support, and recognize outstanding young engineers' talent from all around the region. CIBSE NZ Training 2024. We have hydraulic services course coming up on the 21st in Auckland in November. This course is almost full, so if you're thinking of joining, make sure you register sooner rather than later. And we also running online mechanical course starting on the 3rd. One more thing for people who want to get chartered but perhaps don't hold suitable academic qualifications, CIBSE now offers a simplified route to chartership, which is a faster and a more affordable way to achieve CIBSE membership and professional registration. And I will share a quick 14-second video with you. Hopefully it works on this. There's no sound, so all right. Moving to the next slide. Nice. Yes, and we currently have a promotion. We offer affiliate membership 15 months for the price of 12. And not to forget that there are lots of resources available on CIBSE website. And last thing, we'd like to say thank you to Sabre Recruitment for supporting CIBSE NZ annual program of technical seminars and young engineers networking events. All right, so I think I've covered everything. Yes. So let's move to the real reason why we're here. You didn't come here to hear from me, but to learn from Mike Cox, who will be discussing ductwork construction and its impact on energy efficiency. I know that Mike has included a couple slides about himself, so I will leave the honors of introducing himself to him. And please join me in welcoming Mike. Thank you. I'll stop sharing.
Yeah, I'm just going to share My screen now. All right, so Anastasia, I assume you can see that screen clearly, duct construction?
Yes, yes, perfect.
Yeah, thank you very much, CIBSE, for this opportunity. And thank you, everyone, for dedicating an hour of your time to this talk. And my hope is that you're about to walk away just with maybe just a tiny bit more knowledge than what you already have. So just to give you a bit of background, my name is Mike Cox. I'm a recent immigrant from South Africa, live in Auckland, have 3 children. One is 11, the other one's 16, the one is 18. Been married to my wife for 25 years, the girl of my dreams. I told her I was going to be a doctor, and she obviously didn't hear me correctly. She thought I had ambition, but I've been in the ductwork industry most of my life. So I started as a tradesman, manufacturing pre-insulated ductwork in South Africa in 1993. And I then studied business management, transitioned to sales, and then management. And then in amongst that, I moved into sheet metal as well. And then I started and I led a duct shop in South Africa from 2005 before selling it in 2020. And COVID happened. We were trying to come over to New Zealand, and eventually we got over in 2022. And today I am the business transformation leader at Cook Industries, where I lead improvement initiatives throughout the business. In 1997, while working as a tradesman, making PAL, pre-insulated ducting, I got a call to assist on an urgent project at National Panasonic in Kuala Lumpur. The client had moved hundreds of staff into the building, but commissioning was incomplete. The reason the commissioning had not been completed is that many of the plant room duct connections had failed. When I arrived there, I found many return air ducts near the air handling units had collapsed, and most of the supply air bends coming off the units had come apart. And this was my first real introduction to duct leakage at a catastrophic level, and the importance of following construction standards. HVAC, as we know, has a bad reputation in energy consumption, consuming up to 40% of energy in commercial buildings. Since the early 2000s, there's been a significant push for improved energy efficiency, and accelerated further in the United Nations Climate Change Conference of December 2015. And as we all know, there's a global drive in HVAC to create better efficient solutions, better energy efficient solutions. From heat recovery wheels, air-to-air plate heat exchangers, heat recovery wheels, ERVs, HRVs, vacuum degassers, reversible heat pumps, duct sealing technologies, high-performance insulation materials, and solar-assisted heat pumps, etc., etc. The list goes on. There's been a huge drive to reduce our impact on contributing to global warming from our industry. And if we're going to slow down global warming, consulting engineers and key role players have a critical role in steering their industries in the right direction. My role today is to help remind you that ductwork is crucial in distributing energy and these technologies that are being developed. And from a manufacturer's perspective, where the energy risks lie in duct construction. How to minimize these risks on your projects with hopefully a little more knowledge to help you on your journey in contributing in reducing global emissions. In simple terms, leakage is the loss of energy. There is an increasing demand from building owners, architects, and engineers to produce energy efficiency in buildings. And I'll be referring to the US to United States references quite often, because generally they have the most data available. The US Department of Energy has recognized that ductwork leakage is one of the biggest contributors in HVAC energy consumption. Duct leakage of 15% increases the amount of fan power required by 40%, not to mention the cooling and heat losses. According to the US Department of Energy, unsealed ducts can result in a loss of up to 30% of the system's airflow and more. Recently, there's been a major shift from ASHRAE, and in ASHRAE standard 90.1, they recognize the impact of duct leakage on energy consumption and indoor air quality and requires duct to be sealed to SMACNA seal class A, regardless of pressure. This means that all seams, except spiral lock seams, joints and penetrations in medium and low pressure return and exhaust ductwork must be sealed. 90.1 requires air leakage testing for at least 25% of the installed ductwork surface area in systems operating over 750 pascals of static pressure. Additionally, 100% of ductwork located outdoors must also be tested. And the demand for low leakage, energy efficient HVAC construction and green HVAC buildings will only continue to grow. A commercial building in the US with the US Green Building Council's design certification increases its sale price of between 10 and 13%, according to the Institute for Building Efficiency. So just to reaffirm, ASHRAE standard 90.1 requires duct to be sealed to SMACNA seal class A regardless of pressure. And that means all seams. So in this talk, I have the pleasure of covering. I thought I would give you a bit of history on ductwork. Then we're going to be going into the different types of ductwork, some ductwork construction standards, the leakage risks and how to avoid them, the dynamics of a duct shop and how it impacts energy consumption, and obviously what you're here for at the end, which is the key takeaways. I'm going to have a little bit of a humor in the middle, just to try and keep everyone awake around about the midsection. This presentation does not include insulation, site work related, or any site work related to duct installation. It's a practical overview of duct construction and explains the root issues related to duct leakage. So let's kick off with the history of ducting. The Greeks and the Romans were pioneers in heating technology, utilizing underfloor heating systems known as hypocausts. This innovative approach involved raising floors on pillars, enabling hot air to circulate beneath them, thus providing a comfortable living environment. As time progressed, the Industrial Revolution in the 18th and 19th centuries marked a significant advancement in heating systems. Heating systems such as radiators were introduced, allowing for centralized heating in large buildings. This development revolutionized how spaces were heated, making it more efficient and effective. Additionally, the era saw the emergence of mechanical ventilation systems powered by steam or water. These systems were designed to enhance air circulation, further improving indoor air quality and comfort. And today, these advancements laid the groundwork for modern heating and ventilation technologies that continue to evolve today. The evolution of heating and cooling systems in the 20th century marked significant advancements in ductwork technology. In the 1920s, forced air heating systems emerged, utilizing ducts to effectively distribute warm air across residential and commercial buildings. This innovation laid groundwork for more complex climate control systems, and by the 1930s, the invention of central air conditioning systems revolutionized indoor comfort, necessitating the integration of ductwork not only for heating but also for cooling. This dual functionality increased the importance of efficient duct design in modern architecture. Following World War II, rapid urbanization heightened the demand for reliable and efficient heating and cooling solutions. This surge led to further innovations in ductwork design, materials, and enhancing performance and energy efficiency in response to changing lifestyles and building standards. So now on to modern ductwork. Throughout its history, sheet metal ductwork has evolved from simple handcrafted components to highly automated construction that play a crucial role in modern day HVAC systems. And just a bit of my experience with that is over the years, I've had people ask me to make various things for them. I think we even made a Land Rover door for someone out of aluminium. That's where a lot of sheet metal workers came out of automotive industry. But yeah, it's quite a massive industry in sheet metal. Advances in materials, manufacturing processes, and design technologies have continually improved the performance, efficiency, and durability of sheet metal ductwork, still making it by far the most widely used type of ductwork. Flexible ductwork started growing in the 1960s to 70s. Its invention was driven by the need for a more versatile and easier to install alternative to rigid metal ducts. The introduction of pre-insulated ductwork in 1965 marked a significant turning point in the industry. Innovated by Claudio Ferraro from the company Pell International, these foam-based ducts made a great advancement in HVAC installations by providing excellent insulation properties without the need for external insulation. And that's the industry that the type of ductwork that I actually started with, was with Pell International. And the managing director at the time, Gino Vincenti, he came and trained me in South Africa when we were doing some projects. So I've got quite a long history with Pell and another company called Cool Duct. Fabric Air Incorporated were the first to introduce fabric ducting in 1973, offering a lightweight and customizable air distribution system made from a variety of fabrics. Now we're going to be getting into the nitty-gritties of actual construction. And as fabric ductwork is in the conditioned space, and we're not concerned about air leakage on fabric ductwork, and flexible ductwork is associated with second fix. For the remainder of this talk, I'll be focusing on the two primary types of ductwork, that is sheet metal and pre-insulated ductwork. So starting with sheet metal ductwork, from here I plan to take you on a bit of a construction journey. While there are a range of duct construction standards, SMACNA, founded in 1964, which stands for the Sheet Metal and Air Conditioning Contractors National Association, developed from a need for standardized practices in sheet metal and HVAC construction. It quickly became a leading authority, creating comprehensive standards for ductwork and HVAC systems that address design, fabrication, and installation. SMACNA's standards, known for their rigor and practicality, are widely adopted globally, reflecting ongoing industry advancements and contributing to consistent high-quality HVAC practices. Over and above SMACNA, we obviously have British standard DW144, European standard EN 12237, the Australian New Zealand standard ASNZ S4254, and South African standard SANS 1238. And from what I can see, they're all derived from SMACNA, but SMACNA still is the most comprehensive. So when we speak about loss of energy, and we now start looking at what the key leakage risks are, we speak about seams and joints. Seams mostly run longitudinally along the length of the duct, while joints run transversely. Each section of duct can have 1 to 4 seams, depending on how large or complex the duct is. Large ducts and fittings can have more than 4 seams, such as when sheets need to be joined. The Pittsburgh and the snap lock seams are the most typical seams used in low and medium pressure systems. Pittsburgh locks are the most commonly used in New Zealand. I'm not sure about Australia, but don't necessarily have the least leakage. Interestingly, unsealed button punch snap lock longitudinal seams have been tested by ASHRAE to have an average leakage rate of 2.5 times less than unsealed Pittsburgh locks for rectangular ducts, as can be seen in figure 13 on the right-hand side. So this is the first opportunity for you to reduce your leakage, and that is just to request snap lock, button snap lock on your projects. Just a word of caution. I recommend that companies that are using snap lock are using North American and European machines. I have bought snap lock Asian machine, and it was problematic, and eventually I had to throw it away because we were not able to get the ducts to seal properly. So it's like anything, if you've got the right equipment and you're using the right technology, in this instance it's the button snap lock, it'll perform and it will give you the best results. Other common seams are standing seam, flat lock seam, and the grooved flat lock seam. Here is a video showing a seam being closed. Improperly formed or improperly completed seams are a common cause of leakage. If a setting is off on the seam forming machine or the seam closing machine, the seam will not close tightly enough, which presents a potential energy loss. And that's why maintenance in factories are so important. These settings can go out very easily over time, and good maintenance makes sure that that does not happen and you get the least amount of duct leakage on your jobs. Most of the time, where we do find that the seam is compromised, it's normally the beginning or the end of a duct, where the machine enters and exits the duct. That is a perfectly closed seam. the next slide will be an imperfectly closed seam. Our guys in the factory, I think they had a bit of difficulty trying to do an imperfect one because they trained to make perfect ones. So it might be a slight exaggeration of what a bad seam looks like. But essentially, when you start seeing ripples and you start seeing gaps in those ripples, that is a potential energy loss. Here we see a longitudinal seam being sealed correctly on the inside of the duct as required by ASHRAE 90.1. That does, if you do have, if your outside seam was not closed properly, then this does help to prevent leakage. But you obviously want to close that seam in the first place correctly. Okay, so now we've covered the seams. Now we're going to be going on to the duct joints. S&drive joints. If you look at this joint, you can see we have a drive slip in blue and a S in pink. We called it S&drive slips. The drive typically goes on the top and the bottom of the ducts and the S on the sides. If you're looking for the lowest leakage type joint, I would avoid S&drive joints. And you'll see why in the next video. While they're cheaper to manufacture, S&drive joints tend to have higher leakage rates because they rely on friction between the metal edges with no seal between the joints. Without the additional sealing measures like sealant or tape, these joints can allow more air to escape, particularly in higher pressure conditions. See how that gets finished off. It's just far more potential for leakage on those type of joints. So if you're going to, if you're wanting the lowest leakage on your jobs, you've got to go for flange joints. These are typically more robust and can be sealed more effectively because they use mechanical fasteners like bolts along with gasket sealings, and they create a tighter seal. Slip-on flanges and TDC flanges are the most commonly used for most HVAC duct systems. The slip-on flanges are attached to the duct using self-tapping screws or sealed pop rivets, helping to create a secure and low leakage connection. Good quality brands typically come with an integrated seal within the extrusion, which when fitted correctly provides a high quality seal. Yeah, you can see that seal on a slip-on flange. So this is a quality flange, and it's sometimes not easy to see if that seal is actually in there. And I would recommend that you specify any slip-on flanges used on your projects must have an integrated flange seal. That really is what seals off the flange when it's attached to the duct. Ductmate and is one of the good brands. Mez is also another good brand. There are other good brands. So the other type of flange we have is a TDC flange, which stands for transverse duct connector. This is a picture of a TDC flange without fitted corners. TDC typically has lower leakage compared to slip-on flanges, and here's why. TDC is factory formed from the duct wall itself. which I'll show you in the next video, which when joined correctly provides a tighter seal. Slip-on flanges can still be quite effective at sealing, but they may allow slightly more leakage if the flange is not seated correctly. If it's just 2 or 3 mils out when it's been knocked on, it may mean that the integrated seal did not activate, and you could get some duct leakage where that is eliminated with TDC. TDC is widely preferred in commercial duct systems for its balance of speed, manufacture, and ease of installation, as well as lower leakage. Yeah, you can see a TDC. There's a flat sheet going in the one side of a TDC machine. We've got multiple formers, multiple stages, and it is going to turn that flat sheet. The end of it's going to turn into a flange. So the TDC flange advantages, as I've said, less leakage, reduced labor costs because you don't have to fit a separate flange on to the duct. The cost to make the duct is less. The speed and volume of automation we have a fully automated duct machine here, and the reason why it's fully automated is because we've got an integrated TDC line within it. It's called a transfer line, and we are able to fully automate the manufacture of that duct. So we can make duct very quick with that TDC flange. And we're also not limited by the flange material. So if your duct is made out of stainless steel, aluminium, mild steel, galvanized steel, whatever it may be, your flange is obviously going to be made out of the same material. Where I think, as far as I know, you're going to be limited to galvanized and stainless steel for slip-on flanges. So now that we've covered our flanges, equally important is our sealants. And the first key to meeting low leakage requirements is to simply use a high quality duct sealant. A quality sealant is one that is flexible during application and stays flexible over time. Flexibility allows the sealant to move with the mechanical vibrations and expand or contract due to the pressure and temperature cycling without cracking. It should also have good metal adhesion to prevent air loss at the point of sealing. So as far as plastic wrap is concerned, which duct shops should be doing to keep the inside of their ducts clean, do not use plastic wrap on interior sealed duct until it is cured. Sealants cure by evaporation. If the interior air becomes saturated, the curing process will stop. And depending on the amount of sealant, installers can find uncured sealant when they unwrap the ducts weeks later. Ducts should not be installed, loaded, shipped, or handled when the duct sealant is in a semi-cured state. Semi-cured sealant has not developed film strength and will tear. And tearing of semi-cured sealant is a very common failure and almost always misidentified as cracking. I did say I wasn't going to speak anything about installation work, but because flange gaskets are so important, I'm going to cover a small part of it. There are two different types of gaskets commonly used. Butyl has a sticky clay feeling to it, and neoprene foam gasket. I personally prefer butyl and have had lower leakage on my projects with butyl. It's messy, I know, but it sticks, and a good quality butyl, hyper sticky, super flexible, low temperature, high temperature, you name it. Regardless of your preference, they should both have the following properties: excellent adhesion in strength, should remain flexible and elastic without cracking over time, should have a temperature resistance of -20 to 90 degrees C, should be moisture and chemical resistant. They should be UV resistant because you never know when it's going to be used for an outdoor installation. And I recommend using quality brands such as Duradyne, Ductmate, or similar. I do have some tables that I can share on both sealants and flange gaskets. If anyone would like them, they can just contact me afterwards, and I can email you some examples of the chemical characteristics you should be looking for. The application of the gaskets is equally important. If you are using a butyl duct gasket, you should have an overlap. The gasket will go completely around the duct, and where it joins, you have a slight overlap. If it is neoprene, it will butt together. On the mating duct flange, you don't need to put a gasket all the way around the flange. You only need to put it on the corners, and I'll explain to you why on the next slide. So the reason why we focus on these corners, and you can see this arc over here, and it actually will protrude slightly inside the duct, is we're trying to get that gasket to go over the flange, the seam, and then the flange again. If that duct gasket goes, let me put my pointer on here. If this were to go straight across and over there, there is a chance that if you did get leakage, your seam wouldn't be sealed by the gasket like it would be over here. Obviously essential to fit cleats and clamps to SMACNA standards to the correct spacing according to the pressure class. And that's it for rectangular ducting. We now going to move on to round ductwork. And just like all ductwork, the energy loss risks are in the seams and the joints. The seams on round ducts are generally the same as rectangular. One of the simplest joints in a round pipe is a crimped and beaded joint. This joint works simply by sliding a crimped smaller end into the next pipe. It is essential to manufacture these pipes as round as possible. The beads add strength and rigidity, but if they aren't formed properly, they can create tiny gaps. And where you get these gaps, you get leaks. During manufacture, it's important to ensure the bead is evenly shaped and doesn't distort the pipe's roundness. Poor crimping can also cause distortions in the pipe and another potential leakage risk. What you're seeing here is a good quality duct being made over there, so you wouldn't expect there to be too much leakage on it. However, if you're looking for the lowest leakage pipe, spiral ductwork should be your choice. Spiral ducting has fewer joints and seams, able to be made in up to 6 meter lengths, resulting in fewer joints, therefore less leakage, and if you compare it to standard round ducting, it's just got way less leakage. And that's why ASHRAE 90.1 says that spiral seams, one of the few seams that do not need to be sealed. So that's another tip. If you're looking for low leakage on your jobs, ask for spiral ducting. Okay, so now we're going to go onto the joints. The three main ways we join our round pipes, slip joints, gasketed slip joints, and flange joints. Our standard slip joint is not sealed; it's only sealed on site. The gasketed slip joint is self-sealing, a good gasketed slip joint. And then we have a flange joint, which is mainly used for larger ducts or your higher pressure systems. We have other types of joints which are not common. The one on the left is not common in HVAC. This is called a clinch and a clamp joint. That's traditionally used for dust extraction, pneumatic conveying. The pipe on the right-hand side is a American brand type joint. It's called Easy Flange. I haven't seen it here in New Zealand. I'm not sure if you have it in Australia. We didn't have, I think I saw it once in South Africa. It's not cheap, and you need to have enough work coming in and jobs being specified with Easy Flange for stock to be available. But just so you know, in case you do see it one day, you can say, okay, I remember seeing it on that slideshow. Okay, so we're now going to be moving on to pre-insulated ductwork. Pre-insulated ductwork commonly consists of a 22mm sandwich panel with aluminium inner and outer skins, and a choice between phenolic and polyisocyanurate panels. Kingspan cool duct. The original phenolic foam board is UL 181 certified for excellence in fire and smoke. So what happened at National Panasonic in KL in 1997? Shortly after arriving, I climbed up in the ceilings and found the following. The first thing was some of the ducts were large, up to 3 meters wide. Some of the return air ducts had positive pressure stiffening, but no negative pressure stiffening on a return air duct. Many of the mitered seams looked like they had either used the incorrect glue or the glue was over-cured and the seams did not bond correctly. There was generally a lack of training and quality control in the fabrication of the duct. My job was to train the local HVAC company, which they were trained, and originally we don't know how it landed up getting to that situation. I trained the local teams on the correct construction methods and replacing ductwork where required. The correct stiffening was used according to the correct pressure class. Yeah, you can see the stiffening over here. When you get large ducts, you want to split them into multi-duct sections like you see here, and these little holes here are to ensure we have equal pressure through the duct. So this was fabricated. These are three you can see it's quite a big offset there. 3 separate ducts joined together to form one. And we simply just followed the correct construction methods and managed to rectify a bad situation within a few weeks of working long hours. In conclusion, the failure of the system was entirely due to inadequate training and quality control. There's nothing wrong with PAL ducting. It was people. Okay, so just here's a bit of a funny situation. So when I was, it was my first work trip to Asia, and when I arrived there, they took me out to dinner, and we had all sorts of strange meals like that. And at the time, it was strange to me. And what happened is I needed the toilet the next day quite badly. And I was in the factory and there were all these line workers. And I ran up to the first one. I said, "Where's the toilet?" And they just pointed to the toilet. And I ran inside and I was completely confused on how I'm going to use it. And anyway, I landed up coming out drenched. And the funniest part was when I then spoke to them afterwards, they said the European toilets were next door. Anyway, that was my little humor in between. If you're still awake. So this leads us back to the importance of standards. And in 2009, SMACNA began to study phenolic duct construction, and by 2012 had assigned a task force to use industry experience to develop a standard for construction of phenolic ductwork. SMACNA submitted these standards to the American National Standards Institute to achieve accreditation for an approved material and construction standard. The 2015 SMACNA phenolic duct construction standards were published as a baseline to officially bring pre-insulated ductwork into SMACNA compliance. We also have DW144, HVAC DW144. Though primarily designed for sheet metal ducts, the standard from the Heating and Ventilation Contractors Association is often used in conjunction with pre-insulated ductwork for installation and performance criteria. We also have the European standard 13403 that discusses ventilation for buildings using non-metallic ductworks. And while there are other standards available, SMACNA provides the most comprehensive guidelines for phenolic duct construction. Therefore, I would advise specifying pre-insulated ductwork to be constructed in accordance with SMACNA phenolic duct construction standards for the best compliance. So that's another tip. So here we can see a pre-insulated duct being manufactured. Those are called tiger connectors. The importance of using all of the right accessories, tapes, and everything is critical for the system to work like it's designed to. I will refer to PAL and Cool Duct because PAL invented pre-insulated ductwork, and Cool Duct were the developers of the phenolic panel. Cool Duct is also UL listed and worked in conjunction with SMACNA to produce the phenolic SMACNA duct construction standard, and therefore have the most comprehensive information available. There are other good quality brands out there as well. So pre-insulated ductwork can offer numerous benefits, especially low duct leakage. In a comparative study on two identical properties, the air leakage rate from the Kingspan cool duct system was shown to be 79% lower than the sheet metal system insulated with glass mineral fiber. In order to illustrate this point, Kingspan commissioned a review by independent testing and research organization BSRIA of the implication of duct specification and different ductwork air leakage rates on energy consumption. The methodology given in BSRIA's report was used to compare a 100-meter run of ductwork fabricated from Kingspan cool duct system of 100 meters long run of galvanized sheet metal ductwork. Both runs had cross-sectional internal dimensions of 600 by 600 millimeters. The BSRIA demonstrated that ductwork fabricated from the pre-insulated duct system can save 31% of the energy, and thus cost required to run a fan in an HVAC system with a typical design flow rate of 7.5 meters per second. This saving can be even greater for lower design flow rates. Kingspan commissioned a review by independent consultants Ryder, Levitt, Bucknell of the implications of reduced fan power on actual energy usage. And Ryder, Levitt, Bucknell concluded that the Kingspan system could save 3,100 kilowatt hours per annum. This energy saving equates to a saving of 1.3 metric tons of CO2 equivalent emissions per annum. So we can see that duct leakage, and it always was when I started working with it in the 90s. That was their number one selling feature that they were promoting, was the lower duct leakage. Besides that, you have reduced site labor time and costs. Ducts can be made in 2.95 meter lengths. That's a typical length of a board. And so therefore, if you compare it to a 1.2 or 1.5 meter long duct, it's about twice that length or more than double that length. So you're having half the amount of joints. And combined with lighter ducts means you've got a faster and lower cost installations. They also promote space saving, as the ductwork does not need to be insulated after construction. It can be installed flush to the ceiling and can save up to 200 millimeters of space in the ceiling. It's also fiber-free, rigid, has a fiber-free rigid insulation core, and it is 75% lighter than steel ducting. But it's not all rainbows and unicorns, as you saw in KL. The risks are, there's no formal apprenticeship in Australia or New Zealand that I'm aware of. I stand to be corrected, but I don't know of any. There's a multitude of pre-insulated ductwork not being assembled to SMACNA standards. And there's a plethora of worldwide suppliers supplying boards, flanges, and accessories which may not comply with SMACNA. The video of cool duct that I showed you is using CNC machinery. However, it can be done very easily with purely manual hand tools, which means it can be done on site, or it can be done in someone's garage for that matter, which opens it up to some real manufacturer's non-compliance risks. Different duct boards require different glues for the joints to bond correctly. When I spoke about it's not only that, but it's also the application of the glues. When I mentioned previously over-cured glue that's in KL, to me it looked like they'd left the joints possibly overnight. They'd applied the glue and then only assembled the duct the next day. The way that the glue is applied is really important, and the time from when the duct is joined is really important. So polyisocyanurate board and a phenolic board do not use the same glue. I've tested it. They don't work well on each other. There is a large range of tapes and sealants available, and I've seen companies use a mix and match of different brands of boards, flanges, glues, tapes, and sealants with potential to create a cocktail mix of potential leakage risks to projects. Another risk is that typically in my experience, the training courses outside the US carried out by suppliers of pre-insulated ductwork are only a few days to a few weeks long, which is a far cry from a 4-year sheet metal apprenticeship. So this is my opinion. I believe the best solution should be that a qualified sheet metal tradesman with pre-insulated ductwork accreditation should be overseeing the fabrication and quality control process. This would ensure that the people manufacturing this ductwork would already have sound knowledge of SMACNA standards. So that brings us to the end of understanding duct construction and the various risks. And I'm now going to discuss the dynamics of a duct shop. A duct shop is what is known as a jobbing shop. And almost every order is unique, requiring a wide variety of machinery and skills to produce multiple orders and multiple products at the same time. The workload can change on a daily and sometimes hourly basis, and at times there's great complexity in trying to achieve a deadline when the factory is busy. There may be times that you're running double shifts. In South Africa, we ran for many months at a time, double shifts, 7 days a week. It literally can be an adrenaline rush of trying to keep up with orders from clients. And there are days in between projects when the factory is quiet. But the busyness ultimately has the ability to affect quality in duct construction. If the factory is at its peak of capacity for extended periods of time, quality will begin to be compromised if quality control systems are not in place. And now the emphasis is about delivering the job on time at the sacrifice of air leakage and inevitably energy losses. So, as an engineer, builder, or stakeholder, you may say, this is not my problem. But sooner or later, it will become your problem, and it will impact all of us. As we saw in KL, finding out that there is a problem at commissioning may be too late. So how can you safeguard your projects from these very real risks? Some duct shop owners may hate me after this, but I'm trying to help the industry at large. So here are some practical advice when it comes to dealing with sheet metal duct shops, pre-insulated duct shops. So the first thing is ask your contractor which duct shop are you using and visit them. Look at their quality, knowing a little bit more, hopefully, what I've shown you today. That when you go there with open eyes and just have a look at the quality that's going through the factory, that's coming out of the factory. Is it tidy? Is the factory tidy and well organized? How many sheet metal workers are there, qualified sheet metal workers are there in relation to the workforce? I recommend 10 to 20% of your workforce in a duct shop should be qualified artisans overseeing what's going on. Can they provide signed QC documents for each system on your project? I would request QC documents for example, if you are working on a project that you are really trying to have the lowest possible energy in that design, then yeah, as you get to know the local manufacturers, you will get to know which duct shops produce the best quality. But yeah, I would recommend ask for QC documents, and in there they need to outline in that QC document that they have sealed it according to SMACNA standards. So the key takeaways from sheet metal ductwork. So the first thing is I would request snap lock on your projects to reduce leakage on longitudinal joints. Specify that all seams must be sealed regardless of pressure class, according to ASHRAE 90.1. Specify TDC or slip-on flanges for the lowest leakage. Specify if you're going to use slip-on flanges, they must use an integrated extrusion seal, and specify spiral ductwork over plain round ductwork. And lastly, specify high quality duct sealants and gaskets. And like I said, I'm happy to share the technical data on those. For pre-insulated ductwork, the key takeaways are: specify well-recognized brands that comply with SMACNA standards. I can help you with that. If you ever do want to bounce any brands out there, you're free to contact me, and I will let you know. We currently don't make, since I've been here, we haven't made any pre-insulated ductwork, so we're not representing anyone. I'm very happy just to refer any brands to you if you're looking for some advice. And then specify that all fabrication and installation team leaders are trained and certified by the supplier. So, for example, if it was Cool Duct supplying the boards and accessories, that they have certified them. Specify, so this one over here is my recommendation. You can decide whether you want to include it or not. Specify that qualified sheet metal tradesman with pre-insulated ductwork accreditation is overseeing the fabrication and quality process. And specify that all joiners, glues, sealants, accessories come from the duct brand supplier. And that is to ensure that you don't have different tapes and glues and sealants that are not designed for that particular brand of pre-insulated ductwork. So finally, testing. Testing validates the contractor's quality and helps conserve energy. As we have seen, all elements from seams to joints to sealants to gaskets to training and to standards all play a vital role in reducing our industry's impact on our global carbon footprint. Please make sure that you are doing duct leakage tests on your projects. They are crucial in helping to maintain good construction standards in our industry. Testing is another crucial element of a successful outcome, and I believe that the demand for duct leakage tests is going to increase substantially more over the next decade as the demand for better energy use becomes central to our designs and construction. And thank you. That is the end of my talk.
Amazing. Thanks, Mike.
Well, I'll share
This
that
has
now.
been
Hold
really,
on.
really great, super informative and full of takeaways and learnings. I know that we're running a bit over time, so for people who need to jump to another meeting, please feel free to do so. We're not going to be too offended, but if you have time, please stay behind for questions. I see that we have Doug.
Yes.
Doug.
Hello, Mike.
So yeah, if you have a question, please raise your hand and we'll do it this way.
Yeah.
Excellent. That was fantastic. When PAL, Ducting, Kingspan, Petrie came out 25 years ago, before some people were born here, there was a lot of tests done for fire engineering, and obviously with Greenfell, it's a very interesting topic again.
Yes.
Phenolic foam came out looking very good, and although polyisocyanate still had a 0001, fire service were worried about the content of the toxic smoke that was coming, even though it was only one. Have you got any update on that?
Yeah, it's when we were in, so I was a distributor for PAL in South Africa in the 90s and the late 90s. And you couldn't use polyisocyanurate anything above a second-story building. And so we basically were, just to be safe, just used phenolic.
Yeah.
And what happened is when PAL sold it, so it was an Italian company. They sold it to the UAE, a company in the UAE. They went and had all these tests done, and all of a sudden you could use polyisocyanurate in any height building, which I was quite shocked about.
Yeah.
And so I mean, we're talking skyscrapers, the whole lot, you know. So since then, it still stands, as far as I know, that polyisocyanurate can be used. But I think it also comes down to what the local, what your local legislation is,
Yeah, there's really no legislation here, and phenolics a bit harder to work with, so we don't see that much here.
Yeah.
And there's a lot of advantages with the system. I like it on cushion head boxes, particularly. It takes all that weight off the ceiling.
Yeah.
But and then when you see Kingspan and all the testing they've done, everyone seems to think she'll be right. But in terms of documentation and various fire certificates from various laboratories, it's always a little bit confusing for me.
Yeah. We actually tested the polyisocyanurate in South Africa and the phenolic. We had a fire lab do it, and it's exactly as the standards show, that if you hold a flame to polyisocyanurate, it will just keep on burning. If it will burn.
Self-extinguish.
Sorry, phenolic will extinguish. My apology.
Yeah.
But polyisocyanurate will continue to burn. Obviously not as much as polyurethane, but yeah.
But that was the question in the testing back in Australia and Sydney back in the 90s, was even though it was a very low smoke rating on the polyisocyanate, because it's got cyanide in it, that's what the gas was being given off, and that's what they were worried about,
Yeah.
It's not a lot of smoke, but if it kills you, it's no good there.
No, especially when you're in a office building and you've got a lot of people, and then they can't escape. Yeah. No, I don't know any change to that. But I've always believed phenolic is the safest one to use.
Absolutely.
Yeah.
No one provides it though. I think everyone provides the other option. Like if you look at Hollyoaks cushion head boxes and various other companies that are selling Kingspan copies around town,
Yeah.
Especially in pharmaceuticals, clean rooms. Phenolic's a bit more expensive and it's a bit harder to work with. So
yeah,
you know what that means? That means no one uses it.
Yeah. Yeah, good question. Thanks, Doug.
Any more questions? I don't see any other hands raised. You can just unmute yourself and fire away. Silence. That means, Mike, you covered it all. But I'm sure if anyone has any questions for Mike, he'll be able to answer them later on and help you out.
Yeah. I really think it's a really good thing if people start like you visited our factory. Just go and start visiting the duct shops that are out there. If you're wanting the lowest leakage on your projects, get to know which factories are producing the lowest quality. Yeah.
So can I go for a double, Mike? I've got another question. So testing, as you know, in DW142, it's not so much a percentage, it's a pressure test, So you basically have to blank off all the outlets, and then you have an air pump that you pump up the duct with, and then you measure on your manometer how much leakage you've got on the graph according to the pressure. So that's practice in the UK for all systems and all duct systems. You know, there's never a system that doesn't get tested to that. Here, I've never seen a system tested to that, which is quite strange, really. You know.
Yeah, so they hold you hold the pressure, you see how much air you have to then compensate with the fan, and that shows you what your leakage is. Yeah.
You don't do it here for some reason.
Yeah, I sent an email to Anastasia about the duct leakage, and I said, I know what it's like 10 or 15% of systems get tested. Is that something like that, Anastasia, in New Zealand? Typically, you muted.
Yeah. So I've lost you for 5 seconds. Can you repeat what you said?
Yeah. So your duct leakage test, it's about 10 to 15% of the ducting gets tested. Is that correct?
Yeah, it depends on the spec. If you look at different consultants, specify slightly different figure, and I don't think it's a single number, but if anyone like to share their figures, this is I believe that 10 20, but obviously more risk if we're dealing with high risk systems, when we like to test more of it.
I think the risk in conventional pressure testing like we do now is that if you tell a contractor we're going to test this section of ducting, what is the contractor going to do? He's going to get it as close to spec as he can before you witness it. And you don't know how much remedial work he had to do in order to achieve that. You then witness it and you're like, great, we sign off on it. But if he had done a lot of remedial work on those systems, can it be trusted that he's going to do the same remedial work on the rest of the ductwork, even though that's not been tested, So I know what you said is that, you've got to have trust somewhere along the line, but I think this is where I think over the next decade, it's going to become maybe, it's just you're going to have to test all of it maybe within 15 years, who knows? But I think it's just the demand for leakage testing is going to increase substantially.
Fingers crossed. Let's do presentation in 5 years time and see if there's any change.
Yeah.
All right. I think we can wrap up this session. Thank you so much again on behalf of CIBSE and all attendees and everyone who'll be watching the video afterwards. I think you're leading the change in the sphere of ducting and leakage testing. So thank you so much.
Yeah. Pleasure. Thank you, everyone, for attending.
Does anyone want to add any final?
Thanks, Mike.
Thanks, Mike.
Excellent.
Okay. Pleasure.
Thank you.
If
Thanks,
you
Anna.
want any of the highlights, let me know. I'll email them through to you. You can just get my details from